This is in part inspired by the fact that the way that we are communicating and forming opinions in today's world is ever evolving. And in some sense, the actions that we're taking are informed by very complex and statistical beliefs about the world. So we are trying to understand that a little bit better. I'm a computer scientist, and this is an area that I actually find that a lot of different fields have to come together. Theory of computer science, economics, and many others should come together to actually really address this area. So the talk I'm going to give is actually more of a style of an econ talk, but in a very, very short format. So going back to the complex beliefs that we are forming and are informing our opinions, let's think about an example. Like, let's say that you're trying to decide whether or not you want to vote for a politician. And one thing that you will naturally try to do is to either form or at least justify that opinion by reasonings that feel statistical in nature. Like, what kinds of policies that a politician has supported in the past? Were they ethical? Was this politician bipartisan or not? Similarly, let's say that you wanted to decide whether you're going to take a vaccine today. And so you want to know, is it effective? Is it safe? What kind of side effects I might be experiencing? And these are, again, the types of information that are statistical in nature. They're not just about one person's experience in the world or two people's, rather general statistics about what we are seeing in real life. But at the same time, the way that we actually gather information comes from a different abstraction and different level of complexity, which is that, yes, there are times that we do have a single source of detailed statistical analysis that we can access, and we can read it and we can get the complete picture in one place. These are usually like scientific papers, investigative journalism, pieces in general that have put a lot of different information, pieced them together to build one coherent picture. But much more, especially in modern days, we are getting this information from retelling of experiences that people have had. These are people that we've been interacting with either over social media, at work, or family. And in fact, not just social media, even think about most journalism pieces that we see, often as retelling of some anecdotal retelling of what has happened in real life. And it's not until much later in the stage that we as a community have had time to process information and have observed bigger patterns emerging that we actually sit down and write a scientific paper or an investigative journalism piece that makes a bigger or creates a bigger picture in one place. So what this is saying is that there is really a disparity between the type of beliefs that we need to form to make decisions or justify those decisions, and actually the way that we communicate or gather that type of belief and information. So this is in fact very similar to what happens in machine learning. This is the dilemma between the generalization versus communication in machine learning. And I'm just giving you this example because if you come from a scientific area that works with algorithms or technology, this is the type of thing that you see on regular basis. For example, in some sense, what we are trying to do in machine learning is that we want to have these models that account for when you're generalizing from data. So generalization is like beliefs that are formed from many different pieces, and they can actually apply to things that we haven't seen yet. Versus communication is the stories we tell to justify those beliefs or persuade others. And we want to differentiate between these two. So for example, in machine learning, these two use different types of abstractions. Information and communication are usually about individual samples or data pieces that we've gathered from the world. Beliefs are these more complex functions that describe the actions we can take in any scenario. Sometimes you think about them as posterior distributions, but just kind of more generally, this kind of more statistical nature of a belief that's not about single observations at a time. So this is kind of, I think, a helpful picture to have in mind for the rest of this talk. And let me say that by no way I'm claiming that what we are trying to do, which is to actually think a little bit more about human communication, is in any way the same or even similar to machine learning. But what I think is important here is to realize that the mathematical theory of learning and artificial intelligence and economics have contributed a lot to each other. And this is in particular, this kind of thinking about communication of humans and formation of belief is, I think, one important application where the two of them coming together can actually give us a really good understanding of what's happening. And in particular, I think the fact that the different abstractions that come from AI and machine learning, this kind of abstraction between information and communication, is going to allow us to get a better sense of the social implications of communication we're seeing in practice as well. So there are many aspects to this perspective, like really trying to understand, the disparity between different types of information and different types of beliefs that we are forming. To remain mathematically grounded for this talk, what I want to do is to actually focus on really just one aspect of this. In particular, that when we think about communication with humans, we're thinking of this telling and retelling of some kind of a hard evidence, which of the form of anecdotes. So what we're really thinking about anecdotes are these experiences we've had in life that we've either experienced ourselves or we have heard our friends experience and they told us, and we use them to retell the story that we want to tell in a way that we find justified to tell it. So to do this, I'm going to focus mostly on one paper actually, and this paper is called Persuasion with Anecdotes. This is a joint paper with Nicole Immorlica, Brennan Lucier, Markus Mobius, and Divyarthi Mohan. Okay, so I started talking about anecdotes and individual pieces of information, but what are actually these anecdotes? So going from kind of the intuition of talking about complex versus simple storytelling that I was using, we are going to consider an environment where the communication is retelling of these tiny bits of information. What is an example of an anecdote? So on the left, there's an example of a tweet, for example, I had sent a year ago. And this was about the experience I had when I got my, for example, COVID shot. And I was retelling my experience, which was, I'm feeling kind of fluey and shaky. I have fever, but overall, I'm so grateful that I got this shot. And so this is one person's account of an experience. On the right, we have summarized statistics about the same thing. So this is from a published scientific studies that says, it's not just about Nika's experience or Jacob's experience or Essam's experience. It's about overall, like what actually happens in the world. And it says that, okay, well, about 3% of the recipients of this vaccine will develop severe temporary side effects. And it goes over and over all of these different side effects that you may be experiencing. So the summarized statistics is something that could have been made from actually a lot of these pieces of information, but it's the one that's scientifically written. It builds a complete picture rather than just one person's experience. So that's exactly what an anecdote is in our setting. We're thinking about a person that has access to a lot of experiences, these observations, let's say K of them, and that person decides to share one of these anecdotes. So the person is not going to just make up a completely untrue anecdote, but rather choose from their experiences what they're going to share. Kind of like rather choose what they're going to retweet perhaps on their Twitter account. And at the same time, we're also going to focus more on the aspect that is about persuasion, which is that the person who is actually sharing this information may want to see some kind of action happening in real life. Maybe they want to encourage others to take a vaccine or wear a mask or not wear a mask. Or in just most importantly, they care about what kind of image or what kind of actions are going to be taken as a result of their communication. More generally, we are going to talk about having a strategic communication environment. We have senders and receivers. Let's just take one of each, a sender and a receiver. A sender is talking to a receiver about the state of the world. The state of the world might be something unknown, like what are the health benefits of getting a vaccine or not. Some examples of this are, for example, the news media is the sender, is trying to tell the readers about the current events in the world. Or another one could be a politician who is talking to the constituents about the policy decisions. So these are just two examples of senders and receivers. In particular, there in the two examples I'm giving you here, there's a little bit of information asymmetry in the sense that the sender typically knows more than the receiver. The news media has seen tons of stories and they will choose what to share. Similarly, politicians have thought about the tons of things and have actually information about tons of their constituents as well, but they're only going to share part of the story. There's also agency in the sense that once the receiver actually gets the information, they're going to take actions based off this information. The choices that they're going to make, the actions they're going to take, the beliefs they're going to form is going to be influenced by these. And the sender actually has vested interest in the action that's going to be the outcome of this. So the sender is going to pick a communication scheme or some kind of a policy so that the action that is induced in the receiver is to its desire. Let me give you one other example of this now that we have a little bit more understanding of what you're talking about in terms of senders and receivers. So this is an example of a journalism. This is actually a New York Times top page about, 6 months ago, almost a year ago now. And this is retelling of the names of number of people who died as a consequences of COVID complications. So this newspaper is sending a signal. That signal is the journalist's research into COVID. And they chose a communication scheme. And communication scheme would have been their editorial policy of what kinds of stories are going to appear on the first page of New York Times. On the other hand, we have the reader, who is the receiver here. And the reader is going to form beliefs based on what they're reading in the newspaper. For example, these beliefs could be about the danger of COVID, the effectiveness of the masks or vaccination. And then they're going to take actions based on this, which is, what fraction of the time I'm going to wear a mask? Or am I going to get vaccinated or not? And in many cases, we're thinking about these vested interests, which is that the newspaper here, so why did they publish this piece on their first page? It's because their value held perhaps a little bit more than personal freedom. And they want to see that their readers are going to actually wear masks more often. So there's this kind of a vested interest that this story didn't happen in a vacuum, but because they wanted to see something in the world, they wanted to see a certain type of action in the world. You see a similar kind of example actually in how politicians talk as well, but I'm just going to keep it to one example here. So what we want to talk about is that imagine this kind of an environment and imagine these rational senders and receivers. What kind of rational communication we're going to see in this environment, and how does learning from anecdotes happen? In particular, questions we want to ask are, would kind of strategically cherry picking anecdotes lead to biased choices of anecdotes? Would, again, this type of cherry picking anecdotes impact the quality of the receiver's actions and the efficiency of the communication? And would, again, this type of cherry picking anecdotes lead to almost belief polarization or homophily? So that's the plan for the rest of the talk. To give you a more clear model of what you're going to be working with, we have the sender and receiver. Each of them have sort of a personal preference. We think about these personal preferences as offsets to the one state of the world that is unknown. So I can think about them as theta being state of the world, this is unknown, but the receiver and the sender might fall on two ends of it. Like maybe one of them is prefers everything being equal, values personal freedom, and the other maybe everything being equal, values health considerations. We also have, the receiver will have ability to take actions, and these actions are going to be informed by payoffs that both the action and the receiver will receive. So what are these payoffs? The payoffs are actually the distance between the personal preferences and the actions taken. Note that while only the receiver is taking an action, like this is how to vote, whether or not to wear a mask, whether or not to get vaccinated, both the sender and receiver live in the same world and they will be impacted by the same action. We think about this as the L2 difference just to simplify everything. Okay, there are also observations. So neither of the players necessarily know what the state of the world theta is. So we actually think about it as coming from some distribution. The distribution is known, but not theta itself. However, the receiver actually has some observations from the state of the world. So x1 to xk are IID drawn from this distribution parameterized by theta. So these could be examples of anecdotes. And then the sender has the ability to send one anecdote to the receiver, or a subset of them. Let's just think about one. So they're going to use something we call a communication scheme to decide which anecdote is going to be sent. What this looks like is that they decide this based on the posterior belief that they have formed about the state of the world using all of their observation. And then this becomes a policy that takes all of the observations, but will output only a single one to the receiver. Okay, so this is an example of the anecdote that would have been sent by this sender. So everything else is actually not viewable to the receiver except for the anecdote sent. Now the receiver will get this anecdote, and of course they can form beliefs about the theta as well, using both what they saw and the communication scheme that they know the sender used. So here we're going to think about receivers as actually having action rules. These action rules are going to depend on the communication scheme and on this posterior as well. And what they tell you is what kind of action to take given the observations that you've had. So this action essentially is going to take all the posterior, and the action rule will take the posterior and will actually tell you what action to take. We are going to talk about rational behavior. Here, this is formally defined as a perfect Bayesian equilibrium. For those of you who are not familiar with it, at a high level, what this is saying is that the sender is taking a communication scheme, the receiver is taking an action rule, and the two of them need to be stable with respect to each other, in the sense that keeping the sender's communication scheme fixed, then this action rule is optimizing the expected receiver utility over the posterior beliefs formed by the posteriors and by the communication scheme and by the signal sent through that communication scheme. And again, similarly, fixing the action rule of the receiver, like how the receiver will perceive your actions or the signal sent, the sender will not deviate from the current communication scheme. So this is the equivalent form of talking about Nash equilibrium when there is some uncertainty in the world. So what really essentially are saying is that rational behavior is when neither of the sender or receiver are going to deviate from their strategy. And this is what we want to actually characterize. We want to ask questions of the form, first of all, what does a rational behavior look like? Can we characterize it? And then what is a sense in this? And how do the receivers interpret signals in this rational behavior? And I'll start by first talking about how do we understand senders and receivers' perspective. Okay, so let's go back to what a communication scheme looks like. So I get all of these parameters, all of the IID observations, and I can decide what to send. An example of this is sending the minimum or maximum signal, sending the signal that's like closest to zero, sending the signal that's closest to my posterior belief. These are all examples of communication. We are going to think about translation invariant schemes. These are schemes that sort of don't really care where zero is. They're always with respect to the state of the world and the beliefs. So a useful class of them is actually thinking about, I'll take the signal that is closest to my posterior belief, but shifted by some R. So if this is R, like kind of like thinking about this is that as I take R to go to infinity, I'm picking more and more extreme signals, and the bias on average of the signal I'm picking is also kind of becoming more extreme, but a little bit lagging behind. So from the receiver's perspective, I get that signal, and that signal tells me something about the state of the world that depends both on the signal that I got and the communication scheme I believed was used. And then what I'm going to do is to actually debias this perceived bias in the communication scheme. So what does this look like? It essentially is that, well, I look at what I think is the bias of the current communication scheme used, and I shift by that bias the anecdote that I received. And this becomes my action. well, actually this becomes my posterior, and then I use this posterior to actually make an action, which is the offset. So to understand the choices that the sender has, let's take a look at its cost. And this cost is characterized by a few things. It's an ability to send for it to express any signal at once, some fundamental gap between the moral stances, and in some sense, because this fundamental gap, like the sender is attracted to one type of signal, the receiver is attracted to another type. And there's also potential mismatch between the biases of the sender and the receiver. These form different parts of a cost function that essentially tell you that there is a signaling cost, there is some fundamental gap that doesn't come into play at the end of the day, but there is also this kind of mismatch between the biases of the perceived bias by the receiver and the perceived bias by the sender that opens a door to the sender to try to persuade the receiver. What does this look like? In rational behavior, in this type of equilibrium, there's temptation to persuade. And the temptation is based on the fact that if I think this is what the receiver is perceiving as my bias, I'd rather actually bias the signal even more so. Because when it gets corrected, I'm actually reducing my costs. This is the green piece. The unfortunate part of this is that as I bias signals more, I'm actually entering the part of the distribution that's a lot more sparse. It's the tail of the distribution. And sending signals from the tail naturally has higher variance. So when these two sort of stop each other, we've come to the point that we are at an equilibrium. And this can be characterized actually by saying that you particularly send a bias signal, and this bias, remember this R is how far away you go plus your posterior when you're deciding on a signal to send, can be actually characterized as being proportional to the gap between the two moral preferences. So this is actually quite nice because once you characterize this, you can understand what's happening much more clearly. Let's take a look at this again. I'm saying that the sender's choice is going to pick a signal closest to its posterior plus an R shift. And the implications of this is that, first of all, for any number of observations that the sender has, as the gap between these moral stances becomes larger, this R has to become larger as well. Remember, R is the one that we can take to infinity and its bias, its shift is kind of lagging behind. So as ms minus mr increases, essentially the bias in the scheme has to increase. In some sense, at extreme, we are saying that the sender's rational choice is to send the most extreme, the most left or the most right signal as the number of observations increases, as the gap increases. We also understand that for any fixed gap between the moral stances, as the number of observations increases, the bias has to increase. This is a little bit less less intuitive. What's happening here, we are saying that, well, as the number of observations increases, actually the gap between R and bias of R decreases because we just have a lot more signals here. So the bias of the signaling scheme doesn't lag quite as much. We don't have the issue of sparsity as much anymore. So what this means is that to overcome the fact that these two are related to each other, I actually have to increase R further. So this is really interesting because what it's saying is that actually the more of an expert the sender is, the more of a bias you're going to see. The more you're going to see sort of these anecdotes coming from the tails of the distributions. This will have an implication on the receiver, and the implication on the receiver is that it's going to affect its cost. So all things equal, I know I'm a little bit behind time, so let me go a little bit faster. So all things being equal, the receiver is going to be hurt by the sender's high variance in that signaling scheme, because the farther you go, the higher is your variance. So even though the sender is tempted and is going to send bias signaling scheme, it's not good for either of the sender or the receiver to do this. This temptation to persuade becomes more and more as the gap is increasing. So if you had a choice between who you would listen to, would you listen to somebody who is an expert, who has a lot of information, but also they're sort of moral preferences are different from yours? Or would you rather listen to a novice person who has like only one or two examples, but that they're fully aligned with you? They're completely on the same page as you in terms of what your personal preferences are. This is a complex question to ask, but what I find really interesting is that the answer depends. But in fact, for distributions that are fat tails, and these are distributions we see a lot in practice, what is going to happen is that this irrational choice to listen to somebody who is a novice and is going to match your personal preferences. That's because the min-max signal is going to have a constant variance for these Laplacian, these fat tail distributions. Whereas for very light tail distributions, you actually would rather to listen to an expert. So I find it interesting because what this is saying is that homophily, this tendency to listen to like-minded people, is not something that's irrational. It's not something that's coming from people being uncomfortable talking to people who don't look like them. It's actually a byproduct of rational behavior in strategic environments. So I find this really interesting. There's an aspect of this which is about the reputation of the sender as well. In fact, there are some senders who have ability to save their reputation. In some sense, they have a reputation for a specific kind of a communication scheme. These are senders that stop themselves from trying to persuade. They don't try to say that, oh, you perceive me as this, I'm going to try to even drag you more to the left or more to the right. So these senders, the ones that have a reputation, actually are going to help a lot, because these types of senders, they will not try to persuade you. They will just send you the scheme that is most informative. And we see that in these types of reputational scenarios, actually, we don't see as much bias anymore. So that's it. I just want to wrap up very quickly by saying that there's a lot of work on strategic communication, especially in economics. I'll put the references here for those of you who are interested. But I also think that other fields, computer science as an example, but many other fields should get involved in this area. And in particular, because I think inspirations that come from learning theory in particular is going to help us understand better what's happening in polarization of belief. And what I would really love to see more is that how does this kind of study of anecdotal retelling is going to impact network formation, is going to inform our treatment of biased belief or polarization in networks, and also the design of better social media. This belief versus communication, or what I call generalization versus samples earlier on, is a really interesting aspect of research. It's becoming more and more popular. And for those of you who are interested, one example of this that we also had a recent PNAS paper is kind of thinking about complex functions as describing your beliefs, and then understanding again, what are some challenges that we see, why we see some polarization arriving and sticking when there is really this challenge between trying to communicate simple things, but beliefs being a lot more complex. So that's it for my talk. Sorry that I took a little bit longer. I'd be happy to answer questions.